Alright, dear students, welcome back. After having studied about distance and displacement, let's talk about their time derivatives, the first time derivatives of distance and displacement. We are going to talk about speed and velocity. So, speed and velocity, these two things are very similar to each other, but the only difference between them is speed is scalar quantity, so it's basically rate of covering distance, and displacement is a vector quantity. Velocity is also a vector quantity, vector velocity is rate of displacement. So, if I want to calculate the speed will be just distance covered, the distance covered over time taken. That's it. And similar thing follows for velocity as well. Velocity is displacement over time. Now, whenever we talk about speed, let's try to understand this with the help of an example. Imagine you are starting from your home at 8 a.m. in the morning and you have to get to a destination which is 100 kilometers away from your home. And let's say by the time you reach your destination, it is 10 o'clock, the same day in the morning, right? So if I ask you to calculate the speed of the vehicle, you'd say, let's say, okay, we started at 8, we reached there at 10, so that's 2 hours of journey, and during those 2 hours we managed to cover 100 kilometers, so that's 50 kmph, right? So you could say that the speed is 50 kilometers per hour. Now the question arises, was the speed of the vehicle 50 kilometers per hour throughout the entire journey, or what can we say that the speed was 50 kilometers throughout the entire journey? I guess not, because it's a vehicle first of all, and since you are driving, at times maybe you are stuck in the traffic or somewhere, so your vehicle might not be moving at all. And then if you're on a highway, maybe your vehicle is going easily 80, 90, 100, 110 maybe, right? So the speed of 50 kilometers per hour that we have calculated, it's actually the average value. It's the average speed. So average speed is defined as average speed. It's the total distance divided by total time taken. Right? Total distance over total time gives you the average speed. So during the entire journey, like 2 hours, what is that 110 kilometers per hour speed when you are moving on the highway? What is that speed? It's called instantaneous speed. Instantaneous speed. This is basically the type of speed that you see on your speedometers, right? Speedometer will tell you the instantaneous speed. How fast is the vehicle going at this current moment? That is what instantaneous speed is, right? Now, for finding out the instantaneous speed, you'll have to use the graph, or in case if you have a position versus time relation, you can differentiate it with respect to time, right? And that will also give you the instantaneous speed at any given time, right? So average speed is total distance over total time. Exact same thing follows for velocity as well. Average velocity will be total displacement over total time. And for instantaneous velocity, again, if you have a graph, we'll find out the tangent to the graph at that point of time where you want to find the instantaneous velocity. Or if you have the relation between displacement and time, differentiate that relation with respect to time and plug in the value of time to find out the instantaneous velocity. Let's look at the non-graphical method of finding out the instantaneous velocity. Right? It's a very small process. Say, for example, the distance traveled by a particle as a function of time is given as e cube plus 4t square minus 3t plus 1. So if I have to find out the position of the particle at different time instances, let's say, for example, I want to find where was the particle located at t equal to 0. That is initially at t equal to 0, x 0 equals to, you just plug in the value of t equals to 0 in this entire expression. So you get 0 plus another 0 minus 0 plus 1. So that's just 1. So if I say this is being measured in meters, the position of the particle at t equal to 0 is x equal to 1 meters. So you could say from the origin, the particle was at a distance of 1 meter at t equal to 0. If I have to do the same thing for some other time, let's say 2 seconds, you just plug in the value of 2. So you get 2 cube is 8 plus 4 times 16. So that's 16 and 8 is 24. 24 minus 6, 18 plus 1, 19. I hope the math is wrong. Right, not wrong, right here. So equal to 2 is 19 meters. So at x equal to 2, the particle will be found at 90 meters from the origin. Now, since it is written as x, you can assume that, I mean, basically x implies that the particle is moving in a single dimension. It's moving along the x-axis. Now, how do we figure out the displacement? Or, I mean, this is basically displacement, sorry. How do we figure out the velocity? For finding out the velocity, the idea is very simple. You just differentiate this with respect to time. So, I go with dx by dt. So, dx by dt equals to 3t square plus 8 times t minus 3. So, this is the time velocity time relation between the parameters for this particle. How do I figure out the velocity at any given instance? At t equal to 0, if I find out the velocity, v0 is equal to negative 3 meters per second. You just substitute the value of t equal to 0 in this expression, 3t square plus 8t minus 3, right? And if I have to do the same thing for 2 seconds, I just go with v2, which is equal to 3 times 4, which is 12 plus 16 minus 3, 25 meters per second, sorry. So that's the instantaneous velocity of this particle at t equal to 2 seconds. Now, in more detail, we'll talk about this concept of average and instantaneous speed and velocity in the next video. So I hope you understood this concept very well. Thank you for joining and see you in the next video. Goodbye.